Hello everyone, I'm Aditya Chattopadhyay, a PhD student at Johns Hopkins University. Today I would be presenting our work on learning graph variational autoencoders for conditional indoor 3D scene generation. This work was jointly done with Amazon during my summer internship there. This work focuses on the problem of conditional synthesis of indoor scenes. More specifically, given an empty room layout and room type, say bedroom or library, can we try to synthesize diverse sets of furniture item arrangements that are plausible and consistent given this layout and room type? Prior work mostly relies on hand-designed heuristics like relational graphs or scene hierarchies. This approach is not really scalable. More recently, people have started exploring deep autoregressive models for this purpose. These models generate furniture items sequentially one at a time and have performed impressively. Although deep autoregressive models are very good at generating scenes, they lack a latent variable structure. We argue that having this latent structure is crucial for having more control over the generations. Unfortunately, existing latent variable models are insufficient for indoor scene synthesis. This brings us to our main contribution. We represent room and furniture layouts as attributed graphs where nodes correspond to different furniture items or room items, for instance the walls, windows and so on. Then we propose a VA architecture using graph neural networks for parameterizing the encoder and decoder. Finally, we propose a novel structured autoregressive prior based on linear Gaussian models which effectively captures the structure in 3D scenes. This is in sharp contrast to what is typically done in current VA models, where predominantly it's assumed that the prior is a standard IID Gaussian without any autoregressive structure. Next, we show how using this autoregressive prior greatly improves generations. What you see here in each row is generations produced by different methods for the same floor plan, and each column corresponds to a different method. The first column is a ground truth from the 3D front dataset. The second column is ATIS, which is a state-of-the-art autoregressive model without any latent structure involved. The last column is our proposed method with an autoregressive prior. The two baselines have the same VA architecture with the only distinction being the prior employed. Baseline 1 is a VA with a standard normal IID prior, and baseline 2 is a VA where the prior is again IID normal, but the mean and variance now depends on the room layout. And as you can see, both the baselines struggle to generate good furniture arrangements. For instance, furnitures often overlap with each other or go through the wall. Whereas just by changing the prior to an autoregressive one, as proposed here, greatly improves generations. Finally, we show how an autoregressive prior can also help in control generations. For instance, you could edit the scene by deciding to morph some furniture item into another. For instance, what you see here in the leftmost image is a synthesized bedroom, and by interpolating along the latent space, we can progressively change the topmost cabinet into a chair. Thank you, and for more information, please visit our poster.